Alright folks, new day, new job. Let's see, what are we up to here today? This looks like field work, but it's not actually. I'm at my shop. This is, let's see, let's zoom in here. This is one of those man lifts, I guess you'd call them, or flying carpets, whatever, you know, aerial work platforms or whatever. And I believe this is an electric one. And the problem here is the spindle is bent on this wheel, obviously. Let me zoom out, try to show you from another angle here. Let's see. Maybe you can see the way it has kind of like a, you know, kind of a whoop in it there. So what they want me to do is they brought it to my shop, which is nice, and the reason that's nice is because for something like this, though of course it can be done in the field, but what's nice is that at the shop I have the ability to it's nice to have all your toys with you, you know what I mean? On the road, of course, you know, you usually have enough that you can get it done. But what's nice about this is this kind of has to go in a specific spot, this spindle. I mean, it's kind of important where it goes. So what's nice about having the machine here and me with it and all my toys is that I can, you know, I can do things a lot easier, facilitate them a lot better, and, you know, with a little more finesse than I can do on the road. Case in point, now I have they included a print with this as to how to put this thing back together, which is nice, and I'll show you that in a minute. And of course I have the new spindle, which I can show you here. But the really nice thing about being at the shop is the fact that at the shop I'm able to do stuff like create fixtures such as this, which makes it almost foolproof when I put it back together. This lines up on here, this lines up on here, and the whole thing, you know, is very, you know, is very nicely done, because, you know, again, at the shop I can just walk out here, take my measurements, and, you know, go back inside, and in this case, you know, walk back and forth to the saw and the milling machine and all of that. So that will greatly speed things up and make it a whole lot easier on me. So essentially what we're going to do is we're just going to remove the old and then replace it with the new one. This is the new one. And I guess naturally you can see the way this is. Let me see that. Can I? Oh yeah, I can zoom right in on here. Obviously this is, you know, from the factory. This is, you know, very nicely MIG welded all around. I can certainly do that here. You know, I have, you know, absolutely everything here to do that. But I am outside. My shop is not big enough to facilitate putting this in, or the arrangement of my shop wouldn't facilitate putting this in right now. So, and I'm, I guess we would call it old school kind of guy. So, I'm not a big fan of flux core wire welding. I have it, I use it out in the field sometimes, but for what I would consider non-critical applications. I'm not sure if it has come far enough, or I perhaps have come far enough with it to feel comfortable that I would use it in a case like this. If I had it inside, yes, I'd have no problem just, I'd be completely comfortable just squirting this thing back on. Inside, you know, in a closed-in environment where there's no breeze. Yeah, I mean, it may be 85 degrees or whatever out here, but there's quite a breeze blowing. In fact, I'm trying to stick this in between the raindrops here. So I'm a solid wire with gas kind of guy. That's my personal opinion. I know they do wonderful things with the dual shield now and this and that, but I haven't really gotten involved with that. So my intention here is going to be, I'm going to remove this by air arc. I'm going to air arc it apart, and then I'm going to use my fixture to put on here, and I'm going to use the fixture in combination with putting the new one on, you know, to hold it. I'm going to tack it up, and I'm going to stick weld it back on there. Good old low hydrogen. So I'll get this set up, and you can watch me do it. I'll try to set this up so that I'm far away, because the air arcing can be very messy. So I don't want to screw up the camera here with the, you know, the flash, you know, the flak from the air arcing. So let's see what happens. All right, I guess we're all set up. I'm not exactly sure how to position this to let you be able to watch, but I'll try to make it so that I'm not standing directly in front of it. So I guess I'll try to start with the, you know, vertical, you know, back. This way hopefully I'll be standing off to the side, and you can see some of that, and then I'll go from there. Enjoy. Really fun, folks. This is a riot, as Ralph Crandon would say. Okay, I guess we have sufficiently, let's see, can you see that? There we go. I guess we have sufficiently arced our way around that. So now, I guess we'll get into the removal, which should be not much more than just a simple hammer tap, or, you know, or a few, or wax, should I say. May have to really beat on it a bit, and then it should pop off. And then, of course, if there's any residual, well, depending on how much residual, because that was quite a beefy weld. It was probably like a 1/2 inch weld all around. If there's any residual, depending on how much it is, I'll continue to air arc off the, you know, the residual welds. If it's not so much or not so bad, I'll just do it with the grinder, and then have our clean surface, and then we'll go from there. We'll put our fixture, our alignment fixture on there, and go about putting the new spindle on. So let's see what we got. Jeez, well, how about that? Maybe I'm better at this stuff than I thought. Alright, it's a little warm, but there we go. Here's the good used with the with the bend in it. Alright, actually, you know what? Hardly any residual weld on here whatsoever. This is no problem to just very gently clean up with the grinder, and this will clean up quite nicely, and we'll go from there, and then we'll get rid of this little slag, and we'll go about realigning and repositioning the new spindle. Oh yes, by the way, as I said, since I'm at the shop, and again I have access to all my toys. This is the machine I'm using for this. This is kind of I intend to do a whole video segment on this. This is kind of my I don't know, Franken-welder, maybe, if you want to call it. There's a whole story behind this welder. But this is an amazing welder. Let me try to zoom in on it. This is an awesome machine. It's a Hobart Megaflex 450 RVS, as you can see. This is, again, like everything else with me, this is, I guess as they would term it, old school. This is probably from the late 70s or whatever. This is a great machine. This will do, obviously, as you see me, this does amazing stick work. It's a triple transformed machine. It'll do stick work. It's a very smooth CV machine, so it does great MIG. As you can see, I got one wire feeder there, the Hobart feeder. I keep constantly 045 solid 70S6 in that. And then I also, as you can see here, I adapted a Miller S62 feeder above it. I keep 035 wire in that all the time. But yeah, getting back to this machine, this is awesome machine. This thing, it's an excellent machine. It's just it's very good, very well built. Obviously, it stood the test of time. Actually, I only kind of well, what should I say, put this together, sort of, like early last fall. So like I say, I intend to do a whole video on this to explain, how I got it, what I did with it, and the whole deal. But yeah, this is the machine I'm using here for everything. This will be, obviously, as I say, I used it to gouge it apart, and I'm going to use it to stick weld. I'm going to stick weld it. I'm going to stick weld it back together. So this is the machine I'm using. Alright, so as you can see, let's see, this is going to be our new piece, our new spindle, ready to go on. I have it prepped. All I did was I just very gently ground the edges. What I did though a little bit was I kind of back beveled it. Does that show up? Yeah, a little bit. I just kind of back beveled it on all four sides. Just a little bit. It's only this material. It's only 3/8 thick, so it's not that big a deal. And I believe the material it's being welded to is only 3/8 thick, so it's not that big a deal. But I just figured it would, gives it a little bit of a, another little area to hold weld a little bit better. So we'll be doing that in conjunction with our fixture, and I'll get it tacked up, and then the welding will begin, and I'll try to bring you back in. Okay, we're tacked on. Let's see, can I get this? I'll show you how. All I did essentially was I put my fixture up. Again, it holds, its point is here, and then it holds against the side of the spindle plate here. So, and then this is milled, the bottom of this angle is milled to the exact height of the bottom of where the spindle should go. So essentially that's all I did, was I just lined everything up, put it there, tacked it, and you can see we're pretty well nailed in, flat and flush all around. And I got 2 good tacks on it, and fixture can all come off now, and the welding can begin. And so I'll set it back up, and you can watch me weld a little bit. I won't have you endure the whole thing because that's kind of boring, and I'm going to be moving around a lot, and I'll probably be blocking the shot with my arms and shoulders and everything. So yeah, I'll bring you back in as the welding progresses. Okay, I've begun the welding, obviously. Now, on something like this, where it's kind of, there's going to be a lot of, it's a small surface area, so there's going to be a lot of stress points on it. Something like this. Oh, this piece of copper, way hot, by the way. This piece of copper I put over here just to protect the spindle. I don't want to get any. In fact, you can see over here I kind of had a little arc strike there, so that's the reason for having this over that, is to protect that spindle with the threads and the bearing surfaces. As I was saying, when you have a small piece that's going to do a pretty severe duty task, you don't want to, I know it looks real pretty and everything, you don't want to just start weaving back and forth with your welds. Believe me, it's a little bit hard to resist, but what you want to do, you can see I've got a root pass on here on the top. The bottom's a little bit of a pain in the ass to see, so I've got a root pass on the top, as you can see. On this side here, I've got a root pass, and then on this side I've just started to put another pass. Stringers, you call that stringers. It's not as pretty as, after you have the root pass, you can just start your weave back and forth. It's not as pretty, but in an application like this, where you have a relatively small area that's going to take a lot of stress, I don't know what this thing weighs, but I'm guessing it's a couple, 1,000 pounds or whatever. You don't want, you can do that last. You can cap it. You can cap it with a nice weave, and maybe I'll do that. But stringers is the way to go. Stick your root pass in, and then one on one side of it, halfway into the root pass. One on the other side of it, halfway into the root pass. Then you can cover it up. Like I say, you can cap it. Almost like a term from pipe welding, I guess, or whatever. You can cap it with a nice weave if you really want a pretty appearance. But for something like this, you don't want to you don't want to just put that root pass and then just start weaving back and forth. You really do want to use stringers and something like this. Okay, and there we go. That's about all the let's see, is that better? That's about all the welding I think I intend to do on this. So like I was saying, I went over and let's see, yeah, okay, I went over it, you know, I put the root pass, man, that's hot, the root pass, and then again, like I said, I tried to keep it with stringers. Root pass, one on one side, in this case it was the outer part, you know, towards the spindle itself. I put the root, one on the out, and then one I walked up onto the wall here. Again, not quite as pretty as a wide weave, but you know, here on here I did a weave. I did a root pass, a very thin one, because again this is a vertical. So I did a root pass, I did a thin one on the inside, a thin one on the outer wall, and then I did a weave. On the bottom it's kind of a bitch to see. It's a little tricky. I didn't have much clearance, but again I stuck with the stringers. This side I did a little bit of a weave. Again, I did a root, I did one on the inside and one on the outside, and then just a cap, you know, a cap weave just to cover it. But that's about it. That's plenty of welding on that. It really is, because as you can see from the factory, they only put one pass around the spindle itself to this spindle plate. So I'm more than confident in that, and that's about it. I guess that's gonna wrap up this particular job as far as changing out the spindle on this snorkel lift. Oh, and by the way, no, this wasn't done, like I said, as you can see, it was all done with, you know, very old school, as they say, old school, very traditional methods, stick and this and that. And I don't know if you can see this or not, the rods, nothing special, just regular. These, let's see, these happen to be Lincoln. Oh, these are the Excalibur. I don't think that's gonna read. But anyway, yeah, nothing special, just regular 7018 low hydrogen electrodes. And that's about it. I think, again, I think that's more than enough welding. I think it would have been fine with just, you know, a root pass and then the two stringers. I think that would have been more than sufficient. But now, you know, we have plenty of weld on there. And remember, more welding is not always better welding. That's just that's the truth on that. So anyway, that's going to wrap this up as far as changing the spindle out on this lift, and that's about it. So thanks for watching as always, and as some famous guy once said, everybody polka. See you next time.